Okay, so we're going to cover internal calculators. Okay, we're going to map out kind of decision making. All right, we're going to put a lot of time and effort into what kind of reflects and goes into the inputs for decision making. How many decisions do you think you make per day? It's a big question. But we're going to map out these brain regions here. These are pretty common brain regions that we cover, but I'm going to kind of generally speak on these brain regions, but then I'm going to add in layers of what it means for the autistic phenotype. Okay, so one thing to know is the brain is a prediction machine, right? And it's a metabolic bank accountant. How much energy do I have on board? How much can I allocate? Because my goal is to conserve the energy. So, based off of this situation that I'm in, what areas do I need to activate and inactivate to satisfy my kind of goal, satisfy the requirement of the living organism in this environment, in this situation? Okay, the brain is a prediction machine and it is a metabolic bank accountant. And another thing to understand is you are not reacting to the world around you. You are reacting to the predictions you have about the world and the situation around you. That is a major thing. You're reacting on your predictions of the environment because we're going to talk a lot about predictions and errors because that's a major thing with learning. So if you go into neuroscience or if you go into like learning theory, you can look at prediction, error. Errors are huge for learning. But prediction error is what happened minus what was expected. Prediction error is huge. And you can even break it down if you want to research it. Reward prediction error or aversion prediction error. But just lumping those together because it's okay to separate those. But in reality, the living organism is going to lump those together. So we're just going to call it prediction error. What happened in your life, what happened in that situation versus or minus what was expected to happen. And then that delta will mean a lot of different things. Okay, so let's just pretend like we're encountering a situation. So we have sensory inputs, and then the state that we are in, remember the metabolic bank accountant, what value does that have or potentially have? And value, there's an equation that goes into value. How much control of the situation do I have, or how much control is needed? And then the action. What kind of policy am I undergoing as a living organism here? Okay. Prediction is heavily involved with the sensory. And then the prediction of the sensory plus your state. It's a very big input here. And then there's also prediction with as you encounter the value. Remember, this is a continuous loop. This isn't just a linear thing. So prediction is involved with the value as well, and then how much control do you have navigating this situation? Because we're going to talk about adaptive responses. Because we have a good episode with the Insula and the ACC about adaptive responses and who leads the way, and then the action that you're doing and what kind of policy is that creating for you as a living organism, because that will update our beliefs. You have core belief systems, your phenotype, who you are as a person, or said differently, your personality. Okay, so this is what we're going to talk about. There's a lot of biological energy here. So we're just going to map out sensory with vision because one, I like vision. I like the visual cortex and I like vision biology from the retina. And we have good episodes and whiteboards on the vision biology. You can see this exact mapping with the Corollary Discharge episode. And then you can also see it with the Superior Colliculus episode that we mapped out how easy it is to understand eye gaze for the autistic phenotype. Okay, because we have the frontal eye fields here as well. Okay, so we map this out. Retina will send two pathways for vision. Okay, one is to the lateral geniculate nucleus, which receives about 85 to 90% of the fibers. Lateral geniculate nucleus. And then it will send information to the visual cortex, V1. If you remember, visual cortex will work back inward. But 10 to 15% of the retina's fibers will go to the superior colliculus. The superior colliculus is huge, okay? Because this is that machine-like structure that will just bias your attention to the environment without you understanding it's happening. It's very powerful. And then it will speak up to the medial dorsal part of the thalamus here, which is an executive relay station. It's good for coordinating. And then to the frontal eye fields. Okay, if you remember the corollary discharge episode, this is also sending the corollary discharge. And then the frontal eye fields will speak over to the parietal lobe. Okay, there's two subdivisions here of the parietal lobe that are a region of interest. The lateral intraparietal and the intraparietal sulcus. Okay, remember the parietal is where kind of sensory integration is happening. And then in this very initial, before you even make the eye gaze, remember that's what we're mapping out here. If you remember the corollary discharge episode. And then the parietal will speak back down to the thalamic reticular nucleus here. You should know it by now. If not, this is protective shell. It's a shell protecting the thalamus because the thalamus here is a workhorse. It's a major workhorse here, so it needs help filtering out unrelated and unwanted stimulus, sensations. And then it will go back to the lateral geniculate, and the parietal will also speak to the V2. It will bypass V1. Remember, this is all happening before the eye contact. This starts about 60 milliseconds before eye gaze. Okay, and then it will send this corollary discharge map for a prediction, more prediction. And then once you make eye contact, once you have attention to the environment, you're sending your spotlight of attention to something in the environment. Doesn't matter if it's social or if you're reading, if you're stuck on a topic or subject, like a lot of autistic phenotypes are. This is happening. Remember, we drew this out. But if you want to sustain your eye contact, if you want to sustain your attention, this will also run back. And it will help the frontal eye field say, stay here. Keep your eye contact here. And it will also, remember, the frontal eye field has a bidirectional signal to the medial dorsal thalamus and the superior colliculus, okay? So this is receiving the sensory information via vision. What happens next? Okay? But for the autistic phenotype, you know, because of this is all about sensory processing here, essentially. Sensation to perception, essentially the same thing. For the autistic phenotype, this information is coming fast and hard. It's heightened. Okay, so a lot more information is coming in for the autistic phenotype and at more intensity, those higher gamma versus beta and low gamma for the so-called typicals. And this is where a lot of attention to detail is happening, okay? And visual thinking is happening in large part of this visual cortex and all that information coming in, and a little subdivision of the parietal called the precuneus. which is also involved in the default mode network. It's in the posterior part of the parietal. But we're not going to go there right now. But you need to know that because of what we're going to map out here. So now that something is selected in the environment, what situation is this? What situation am I in? So we introduced the orbitofrontal cortex right here, which is right here. Orbitofrontal cortex is right here. And it receives, remember, it receives sensory information fast, not raw information, because that's already processed. That's what all this green is, processing raw sensory information. The orbitofrontal receives the perception of what this sensory information is fast, because this is state. This is all about what state are you in, and state is a very good spectrum. We can use the word spectrum for all of our internal states. That's a better use of the word spectrum. The autism spectrum is very questionable. So this is state. What state are you in? Not region, not like location, not like Indiana or California or New York. What bodily state are you in? So for the autistic phenotype, we talked about, especially in the autism and intuition video, and a lot of different videos actually, that there's, for the autistic phenotype, there is a trade-off here. There's higher weight for precision, okay, versus compression. There's low compression, high precision here for the autistic phenotype, which is in reverse of the so-called normals, the so-called people that don't have this rate of information coming in with the sensory processing and the heightened awareness, the heightened intensity of these higher gamma waves, these early regions being blasted. For the normals, the typicals or whatever, there is this generalization of sensory information coming in. They just compress it into this generalization or a gist, just to send it on, which is very opposite of the autistic phenotype, where there's a lot of detail and getting stuck. The autistic phenotype has a tendency to get stuck and just pay attention to very precise details of the environment. But that is a strength for learning. I've been on this kick about how autistic phenotypes and the biology that gives us autism allows us to have this accelerated learning. Small differences in the environment, though, can be picked out. It's noticed by the autistic phenotype. That's a lot of pattern recognition here. Learning can become so exceptionally fast and stable because I've also talked about, especially in the visual thinking episodes, that there's a lot of databases being built, different catalogs for different categories. Okay, remember the episode, there's 2 episodes on visual thinking alone, and one is talking a little bit about weak central coherence, which is kind of machine learning. Before AI and machine learning, there was the autistic phenotype's brain. That's the original AI. So after the body, the brain is understanding what kind of state it's in to make these decisions, the medial part of the orbitofrontal cortex is coming on board. Okay? Now, if the orbitofrontal cortex is here, the medial orbital is more in the middle, more closer to this midline. And that's right behind here, okay? So It's right behind the orbital. So it's also up here though, just right on the other side of the eyebrows. And this is reward. This is going to help signal what is rewarding. This current experience that I'm in for the specific living organism in the specific time, that will determine how much this reward, potential reward, is from the environment, or if it's learning a task, learning a topic or subject. How good does this feel to me right now? If state inference is less socially compressed, social reward may be automatically, it might dominate the valuation. So this reward little hub with the medial or orbitofrontal cortex, value may depend more on internal structure than the external. Okay, for the autistic phenotype, value, we're getting into value because reward is a component that will equal value. For the autistic phenotype, value is not external. External is too chaotic. Remember, because of this rate of information with the sensory processing. Value for the autistic phenotype is typically internal. And this is part of this deep engagement with these certain domains that you can kind of subject and identify the autistic phenotype gets into versus the so-called typicals, okay? But value isn't just reward, okay? There's a lot of cost involved. How much effort? Remember with the metabolic bank accountant, this is a good part of that right now. Value is reward minus cost. So that brings us to the insula. We have great episodes on the insula and whiteboards. The insula is very lateral, okay? So it's right in here, but it's very lateral. We talk about the insula quite a bit because it's privileged. It's privileged to the brain states that's happening here, what's happening in the brain. It's privileged to the body. What kind of physiology, what kind of feelings am I having in my body? Am I tired? Am I weak? Do I not feel well? Is my heart rate beating too fast versus just right for this environment? Is my heartbeat fast for sitting on the couch versus running? One of those is acceptable. The other one is not. So this insula it's privileged for the brain, the body, and the environment. How is this living organism navigating the world? How do I feel in this situation right now? So for the autistic phenotype, the raw signals are amplified. Remember, okay? And this shifts the equation. Value equals reward minus cost. You can put these in deltas. Deltas, the differences of reward and cost. Is it too costly? Does the cost outweigh the reward? We can put these on seesaws again. Seesaws are always a good thing. It's a good visual representation. If cost increase, when cost increased, your avoidance is going to increase. And that's true with the autistic phenotype. It's true with anybody. Remember, because this is what we're mapping out. This isn't necessarily secluded to the autistic phenotype. There's more cost versus reward. You will find yourself reluctant to engage in that task, reluctant to repeat that task. And this is where preferences and phenotype and personality is being created. A lot of value here. What does the living organism find valuable? When is the living organism having a net gain of reward versus cost? They will repeat that. It's not complicated. And this isn't necessarily because of weakness. It's because the cost term is genuinely larger in this internal calculation. Reward may dominate fully, but there's an intense, sustained focus that's required. This is why, or a reason why, habits are preferred. Okay? Now that the brain integrates reward and cost, the ventromedial prefrontal cortex comes on board. And this is a very powerful hub. The ventromedial prefrontal cortex is powerful. It receives a lot of information. There's a lot of connections running through and out of the ventromedial prefrontal cortex. And it is down here. And it is at the bottom side of the medial prefrontal cortex. Remember, the medial frontal cortex is close to the midline, deep inside the prefrontal cortex. It's right here. And this is receiving inputs from the situation. So the state dependent situation, the expected reward that the living organism might get, okay, the cost. So the insula is heavily weighted with this ventromedial prefrontal cortex. And then the emotional tone. The ventromedial will receive inputs from things like the amygdala and hippocampus for emotions and energy and kind of contextual memory. Okay, last time I was in this situation, this happened. All right. So value here is kind of being understood. This is value. As these little hubs are sending inputs, the ventromedial prefrontal cortex will calculate those. So insula's cost, value is in large part happening here. Remember though, it's a part of the medial prefrontal cortex. I'll just keep that open. One way to think about that, what I just said, is this area right here is the scoreboard. And the living organism will always want the reward to win. It's like the home team. Because as more rewards are being gained, net benefits, the living organism is going to repeat that. It's going to prefer that. And it doesn't matter if it's healthy or unhealthy. It doesn't care. And remember, the brain does not want to work. It just wants to respond. We're going to get to why. For the autistic phenotype, value becomes extremely stable whenever that's internal. And this will support deep focus, that logical intuition. See the autism and intuition episode. Systems reliability. Remember, one way of thinking about that is, what is reliable? What is reliable for you? For me, we're all different. We have different kind of preferences in life. And one thing that this will kind of help modulate or stamp is accelerated learning, especially in rule-governed domains. The structure, CB2, insistence on sameness. Okay? And this will kind of structure, when the structure is clear, this valuation becomes powerful and more consistent. And it doesn't matter if it's autism or not. But sometimes evaluation isn't quite enough. Imagine this from intense inner world and intense preference for that inner world. And know the so-called default mode network. Remember that I provided a large hub for the default mode network right there. And autism means self. So as we're mapping out these hubs, you can see why the preference is internal. And understanding that intense raw sensory information here that's going to bias us inward versus outward with all that chaos. Sensory processing, this is what this is. The biology that gives us autism here allows us to be comfortable within ourselves. That insula is a very powerful hub for what I just said. Okay, and that leads us to the ACC. The ACC and insula and the medial prefrontal cortex are all powerful regions. Remember, the anterior cingulate cortex is also in the medial prefrontal cortex. And it's very medial. And it's also right through here. The cingulate is very powerful because it's wrapping around white matter tracts. This is your controller. The ACC will tell you how much control that it's going to need and put forth. All right. The ACC is very powerful. It monitors very powerful things. So roles of the ACC is conflict monitoring, monitoring uncertainty. All right. And it's how much effort and cost is associated with this. Risk reward. It's evaluating risk and reward quite heavily. And error detection. That's a huge part of learning. Error detection. And what do you do with those errors? Do you analyze them? Do you accept them? Or do you kind of project them out or kind of spin up reasons of why those errors happened? And those will always be external. Mostly. If you do internalize those errors, you might have a lot of negative self-talk. Either way, you have to accept errors. If you want to learn and grow in life as a human being, accept the errors. It's a very powerful source of growth and learning. Don't discount them. So the ACC is kind of help modulating. Is it worth thinking harder? Is it worth performing harder for this outcome? Remember, we have a very good early episode of the podcast. The medial prefrontal cortex leads the way. And in large part, the ACC is doing that. It's helping lead the way. One thing to know that the ACC and the insula is part of the salience network, okay? Where do you spend your spotlight of attention? And now you can understand why. Because of the cost involved, it's regulating how much cost does the living organism need to give up for this environment, for this task, for this sensory information. And the control. How much control do I have over this situation? How much control is it going to take? And just imagine, because humans can do this, how much thought has. There's a lot of energy associated with thought. Humans' capacity to think is infinite. It's not a good thing. It can be. It can, but it's very costly. So now that we've understood state, reward, cost, value, and how much control, the action happens. The action will now happen. Remember, the dorsal striatum of the basal ganglia's inputs. Motivation lives here. Everything that I've just mapped out is kind of feeding into motivation. You don't define motivation. I hate to tell you. You don't define it. Your central nervous system and who you are, based off of these beliefs and phenotypes, if you reverse engineer this and understand your value, defines motivation. Remember, accept these errors and get out of your own way if you want to grow in life. Okay, so that leads us to the dorsal striatum, where motivation lives. And this is part of the basal ganglia. Okay, and it's right through here. What color? Orange. It's right through here. For the caudate. The caudate will circle all the way down, and then the amygdala will branch off of the caudate. The caudate is very large. It has a head and a tail, and then at the end of it is the amygdala. Also a part of the amygdala is the stria terminalis, which is also kind of this circular thing. It's kind of U-shaped thing. But laterally you can see the basal ganglia episodes. We have a lot of episodes and even whiteboards to explain this. The basal ganglia is very powerful. But laterally here is the putamen. I'm going to have to cover up the thalamus here, but the putamen is very lateral, okay? These two little nuclei here is what is our action selection. The ACC is heavily involved in action selection too, but the inputs coming in to the dorsal striatum will determine your movement. I'm not going to spend any time on this video with the dorsal striatum because there are many whiteboards that are fantastic for the basal ganglia. So the main thing here is understand this is where action and policy is living, okay? Because these inputs coming into the dorsal striatum will select your action. If you want them or not, it doesn't matter. This is where behaviors happen, okay? If there's a high valuation, there's a higher action probability, okay? So everything we're doing is leading up to the action. So if the reward is high, your dorsal striatum is going to stamp that and repeat it. This is why things like addiction are huge in the dorsal striatum and the ventral striatum, the nucleus accumbens. This is why whenever the living organism likes things, it's going to repeat those. And that's why habits are formed. We are precisely building habits at this point. All of this build up to this point. Remember, these connections and regions are building a summary. And the living organism and the dorsal striatum is going to accept that summary as repeat.